structure kind of wrapped around it. Collectively, even though it's a capillary bed and a separate structure, collectively that's the renal corpuscle. And then the renal corpuscle's got some parts to it. Okay, so and the parts are the glomerulus and the Bowman's capsule. Or Bowman's capsule is getting its name changed, so right now it's either Bowman's capsule or renal capsule. So you take either.
I know it is Bowman's capsule.
Right. Then the entire rest of it is called a renal tubule, but even then, parts have parts, correct? So even then, the renal tubule has some parts. So what's the name of the first twisted, coiled up part? One might say it's close to the front. The proximal convoluted tubule. Okay. Then you go down the descending loop of Henle. Then you go up the ascending loop of Henle. Then you hit some twisted up tube again. Distal convoluted tubule. Then you find yourself in a collecting duct. Filtrate enters the Bowman's capsule. Urine leaves the collecting duct. So that means somewhere in between, we're going to make it go from filtrate to urine. Yes, which part? Filtrate and the urine. Okay, I'm trying to rewind my message. Filtrate enters the Bowman's capsule. And urine leaves the collecting duct. So in between, you're going to process filtrate and turn it into urine. The job of your bladder is really just to store it until it's convenient to let go. So it's stored. And by the time it hits by the time that stuff leaves the kidney at all, it's fully processed. All right. So I'm going to review the blood vessels, and then we're going to start looking at the model. All right. Now we know in order to process blood, we're going to have to get blood in and out of the kidney, correct? Yes. So in order to process it and get it in and out of the kidney, we're going to have to rely on a bunch of blood vessels. What major blood vessel brings blood into the kidney? Renal arteries. Renal arteries branch. And they branch in two?
Renal arterial.
Not yet.
Segmental arteries.
Segmental arteries. Segmental arteries. So the renal artery branches into segmental arteries. It's almost like just flip what you learned in along around. Segmental arteries branch into lobar arteries. Lobar arteries branch into arcuate arteries. Arcuate arteries branch into
Cortical radiate artery.
cortical radiate arteries, which branch into afferent arterioles. Is that how we have that?
Yes.
Afferent arteriole. From an afferent arteriole, you go into the glomerulus, and the glomerulus is the site of filtration. Now, after that, it kind of depends on the kind of nephron you're in, and where you're at, and all that stuff, but eventually you'll find yourselves in an efferent arteriole. Okay, and you may or may not have gone through a different capillary bed along the way. I'll come back to that in a second. From efferent arteriole, okay, from an efferent arteriole, then you might find yourselves in a peritubular capillary. I'll show you where they are. It's another capillary bed. It's not the glomerulus. It's a different capillary bed for a different purpose. And then if you leave a peritubular capillary, where are you going to go next? Vasa recta. Again, it's a capillary bed, but it's a different purpose. So you can see there's more or less 3 different kinds of capillaries associated with our nephron here, but they're all for different purposes. Okay, and you don't always have you don't always go through all 3. Okay. If you leave the vasa recta, where are you going to end up?
Cortical radiate vein.
Cortical radiate vein, and we're pretty much just going backwards for the most part. Go through a cortical radiate vein, you'll end up in a
Arcuate vein.
arcuate vein. Travel through an arcuate vein, and you end up in a
Interlobar vein.
interlobar vein. So we've changed the name slightly. You can see some tracing coming in your future. From an interlobar vein, where do you find yourselves?
Renal vein.
Renal vein and inferior vena cava. So it's almost matched. All right, I'm going to tell you about the three different capillaries that were in there, and then we're going to pull up the first model. All right, glomerulus is for filtration. So in lecture, we'll talk about the forces that affect filtration and the anatomy of the glomerulus. We'll do a little bit of it here. So because its function is filtration, it's specialized to filtration. So it's going to have things that are different about it than the other two are going to have. The rest of the tube is about reabsorption and secretion. Reabsorption and secretion. If you have cells that take something out of the filtrate and return it to the blood supply, that's reabsorption. Alright, so take it out of the filtrate, return it to the blood supply, it's reabsorption. They can also do the opposite direction. Let's say a molecule got left behind, it didn't get filtered out at the glomerulus. So all is not lost, we got a second chance. So these cells also have the ability in certain spots to take stuff out of the blood supply and dump it into the filtrate. When you go in that direction, that's secretion. So depending on where you are in the nephron, you will do reabsorption or secretion. The nephron is going to be very specialized. From the blood and put it in the filtrate. So secretion is when you want to get rid of something. Reabsorption is when you want to capture and recycle them. Okay, so they are about directionality. Alright, so reabsorption and secretion are what the peritubular capillary and vasa recta allow us to do. Okay, so that's why they get different names. They're not all the same capillary. One of the models is going to make it look like it's almost all the same thing, and they're really not. Peritubular capillaries are wrapped around those convoluted tubules. Oh. Peritubular, exactly. Peri means surround, yeah. Okay. Vasa recta, not so much. Vasa recta is wrapped around loops of Henle. Yeah, so vasa recta capillary beds, but wrapped around loops of